Hello everybody, welcome back. So today's lecture we're going to talk about algorithms. And actually I should say today's lecture in air quotes because I'm really not going to talk very much. What I'm going to do is give you some links for things that you can self-study with and get out of the way and let the material really speak for itself. Now, why am I doing that? Well, historically, this lecture has been structured around a bunch of things that, like I said, are very interactive and they speak very well for themselves. They don't necessarily need me presenting them to you inside a slideshow, inside a video, right? I mean, there's all kinds of meta craziness going on there. So I think that it'll be more beneficial to you to actually give you a chance to experience them fully or in your own time, rather than me blah-blahing on top of their already quite good presentation. So that's kind of the why. Before we get into that, before I let you just kind of explore on your own, I do want to provide a little bit of context. So, as I said, we're going to talk about algorithms. And we're going to talk about them from two different standpoints. All right, so first off, as a working data scientist, you will be often either using algorithms or making them. The work you do might be used by others to make them, okay? So as somebody working in a computational job, you need to think deeply about how it is that you construct good algorithms. And I'm going to say good in two different ways, right? One in the sense that they do what they're intended to do, right? You want to satisfy your employer. You want to make the world a better place by making this thing work right. Makes a lot of sense. But as with many things, and especially many things in the computational world, what we get done in the, quote, right fashion, even if it's right, even if it does what it's intended to do, it can still have unintended consequences. I think all of you are probably very aware of the conversation about social media and whether social media, which was, that was often talked about as this world-saving kind of thing that was going to bring people closer together, actually has brought people closer together, or whether it's just caused loads more suffering and jealousy and polarization, right? This is a topic of ongoing debate. It's kind of happening in the air around you. I'm sure you've at least seen a little bit of it. So the social networks, these algorithms, are they working as designed? Yes. Are they doing what we imagine them to do? Sometimes. Are they having lots of effects that nobody thought about, or at least nobody talked about when they were being put together? Definitely. Okay, so that gives you an idea of the possible scale of the effect of an algorithm which has unintended consequences. Now, obviously, as you do your own work, you may be faced with this same kind of question. So what we're doing today is we're trying to give you a sense of both the first thing, how do you make an algorithm work well? And B, how do you think about an algorithm to try to draw out as much as you can an understanding of where it might go and try to not be surprised by unintended consequences. So those are the two parts of what we want you to think about today as you're going through this material. So it probably helps to start, at least briefly, with an introduction to what an algorithm is. And for that, I'm going to let you visit the Harvard 50 class, the introduction to computer science there. It's rather famous for their presentation. The idea of an algorithm is that it's a set of effective procedures, a set of instructions, if you will. And if you follow those instructions exactly, the algorithm does its job. Now, computers are great at following instructions precisely. Human beings are much less good at writing precise instructions that a computer can follow. right? That's the whole point of getting trained in computer science and programming. It's actually not that easy to learn to be that specific. And things in data science and machine learning also can require that kind of specificity. Okay? So we'll let Harvard 50 speak for that. I'm going to call that an optional extra, right? If you're already quite well trained in computer science, you know what an algorithm is, you can feel free to skip it, but you'll also miss some very funny stuff. All right. After that, let me check notes here. Yeah, so we're going to give you an example of the workings of a pretty complicated algorithm. It's going to be the company Stitch Fix, which gives you essentially their whole point in life is to help people get clothes they want, right? And they do it in a very automated and data-intensive fashion, and it's a surprising amount of moving parts working together to bring this company's clothes to the people that want them. I think this is kind of exciting because at first glance, Stitch Fix, maybe you're a dude, you're that kind of dude, you're like, clothing, I've worn the same t-shirt my last 2 years and never changed it, right? So, okay, maybe you're not interested in fashion, but maybe you're interested in machine learning and optimization and some pretty cool, supply chain management and financial stuff. So the Stitch Fix story is a very cool one from a lot of different views. Then after that, we're going to talk a little bit about the second part, about how can algorithms go wrong? What kinds of things do we need to think about to keep an algorithm on the right path and prevent it from having ethical or other undesired impacts? Okay? So we're going to talk in a couple of different ways here. We're going to talk about how algorithms shape our world, the fact that algorithms really can have a very, very deep impact beyond what we realize. And I think I kind of summarized an idea of that in the social media thing, but it can go even beyond that. And we're also going to let you watch a few things about how passwords work and a little thing with, so that's a TED Talk, actually, the passwords. And we're also going to continue on with TED Talks with Kathy O'Neill and her talk about the weapons of math destruction. So I hope you're excited to go through this material. I know that I really enjoy this stuff, and I think that, again, this kind of stuff really speaks for itself. The idea that algorithms are central to data science is pretty obvious in one way, right? I mean, we're using computers. But the fact that our work can have various kinds of effects, both directly in the computing world and in the social world around us, is maybe a little less obvious. So, good luck with all of it. I hope you enjoy it. Talk to you next time.